type of triangle is this? Isosceles, right? So if you flip to the paper that has not the unit circle, right, and you look at this paper, what's up?
What time does this class actually end then today? Because I don't have.
You want to take a picture of this?
Yeah.
So obviously our 45, 45, 90 is isosceles. So our two legs there are both x's. And here's the memory trick that I use to remember the 45, 45, 90. How many angles there are the same as each other? What is the value that we use to find our hypotenuse? Radical 2. Right? So in the 45, 45, 90, we have two congruent angles. Right? Two congruent angles. And we use radical 2. So our hypotenuse is going to be the square root of 2, which is approximately, anyone know?
1.4 something.
Yeah, it's approximately 1.4. So your hypotenuse is it's just, guys, when you look at numbers enough, you start to memorize them. So it's not like Alina memorized that for any particular reason. I don't know exactly where square root of 2 is useful, except for if you have a square that is 2 by 2. Like the ants marching. Here is my memory trick for the 30, 60, 90. 30, 60, and 90 are all what? Like when we look for just number patterns. Correct. Keep thinking. You're right.
They all end with 0.
They're all multiples of 3. Right? They are multiples of 30, but they're also multiples of 3. And we use, guys, I'm just telling you what works for me. We use the radical 3 here. Now, also, 60 is 2 times 30. And we use 2 here. So I'm just telling you memory tricks that work for me. It doesn't mean that it will work for you. It doesn't mean that you need to memorize these. I'm never going to ask you on a test, like what was Mr. Hudson's memory trick. But when we see that the 60 is twice the 30, we know we're going to use 2. But also, when we see that they're all multiples of 3, we think to ourselves, oh yeah, I'm using radical 3. So here's the thing. Radical 3 is approximately... What's radical 3? Somebody figure it out real quick.
1.4.
No. I think it's like 1.7. Nobody has a calculator out? I was about to say, you came to math and nobody has a calculator out. Which is bigger? Which is bigger, 2 or 1.7? The 2. So your hypotenuse gets the 2 times the short leg, and your long leg gets the radical 3, because radical 3 is smaller than 2. Guys, I don't think I'm like that amazing of a teacher, but if I've learned one thing in my 9 years teaching, it's what kids will do by accident. And you'll memorize 2 and radical 3, and then you'll put them in the wrong place. That's what you'll do by accident, because 3 feels bigger than 2. It's not. Radical 3 is 1.7, right? So we got to remember the long leg gets the radical 3 times the x, and the hypotenuse, which is the longest side there, gets 2 times the short leg.
You don't even have to figure it out. You just know that 2 squared is 4, and then radical 4 is 2. So radical 4 is bigger than radical 3. I mean, yeah, and then you don't have to figure that out.
You're right. That doesn't change the fact that some of you will try and make that mistake, and that's why I'm going to caution you against that. Alina, if you make that mistake, I'm going to write on your paper, you see, radical 4. All right, so let's look at some problems involving this. By the way, why I put this on your paper again, the 45, 45, 90 didn't matter to be on your paper again, but this 30, 60, 90 compares when you're given the hypotenuse as opposed opposed to given the short leg. Right? So if we reference from the hypotenuse, to get to the short leg, we would have to divide by 2. Right? So our short leg is half of the hypotenuse. And to get the long leg from the hypotenuse, we would have the radical 3 over 2, which, guys, this is why I'm showing you the unit circle at the same time. So if referencing the hypotenuse, radical 3 over 2. Okay, now that you're thoroughly distracted,
Yes.
try
You're
these.
so good.
What?
I love geometry.
So, because I hate when teachers teach this without showing,
Yeah.
it didn't print out front and back. I also put the unit circle in front of them.
Oh,
So then we can jump back and forth like, that's where radical 3 over 2 comes from!
That's awesome.
It took
Wish
me
my
way
teacher
too
would have
long.
done that.
It took me way too long in high school to like, the unit circle I thought was just some weird thing that my math teacher was like lying about.
Yeah,
I'm like,
right.
this doesn't make any sense.
And why do I need it? Yeah.
Finally it clicked.
Fun. And see, you do learn stuff even if you don't.
Johnson.
Okay.
Yeah, it's like super common.
Okay. Thank you.
I love that, like, of all the names you would have guessed, I don't even think you guys would have guessed Johnson.
No. I missed you guys.
So, obviously in the first one, solving for GI, no, that's a G, not a J, that would be way too easy, right? In an isosceles triangle, you know that your two legs are going to be congruent to each other. So, in none of these do I care about you solving for the other leg when given the leg. It's either solving the hypotenuse from the leg or vice versa, right? Solving the leg from the hypotenuse. So, in 45, 45, 90, the value that we use to go back and forth is which number? Radical 2, radical 3, or 2? Radical 2, right? So we use the full size 2, not radical 2. We use that in the 30, 60, 90. Here we use radical 2. And guys, if you get stuck on which one is it, can the hypotenuse be twice the length of the leg in an isosceles triangle? No. There's no chance. An isosceles triangle, you can't think about the math of how that would work. It would lay down. And it would not be isosceles anymore. So, to get x here, what's our x? It's just radical 3 times our leg. Right, guys? I don't know if you just don't want to participate or if there's really, if we haven't sunk in yet. But if we go back to our, Sorry, did I say 3? Radical 2.
Oh, yeah.
Did I say 3?
Yeah.
I got too many numbers floating around in my head. So, when we look at this triangle, we're given the short leg, right? So we multiply radical 2 by it and leave it in radical form. So what we can actually write is 7 radical 2. And that's how we have the implicit multiplication that we don't have to put the dot. If you write radical 2 times 7, I would put those things in parentheses. Because radical 2 times 7 very quickly can look like radical 27, which this is not. So I would at least do that, if not even. Yes, so the correct way to write this is the first way I told you guys. But if you insist on writing radical 2 times 7, first off, I would advise don't write it like this. You should write it like this. But if you insist on this, I would just put things in parentheses. Questions? What is DE? Yeah, 3 radical 2. And what is X here? Oh, wait. I heard somebody say 6 and just stop. How are we going? Sorry, go ahead. You can go ahead if you want. So wait, do you want to pull your answer back?
Yeah, I was looking at the 30, 60, 90.
So what do you think this is?
Okay,
This x, b, I can't see it, bc.
Yeah.
What do we do with the 12? Coming back this way.
It'd be divided by
Divided by radical
radical 2.
2, right? So not just 2, we divide by radical 2. So this would be 12 divided by radical 2, which is a messy, terrible, ugly number. Just leave it as 12 divided by radical 2. Don't try to put it as a decimal. That's bad. It is inaccurate. These are tougher. Take a moment. Please write the work on your paper. This is 2 radical 3 at the bottom. If my screen thing gets in the way, it's 2 radical 3 down there. I feel like I should drag that anyways. Oh, now it's gone. Crap. Sorry, I should have put these on a worksheet for you, but I figured we'd just zip through these quick and then talk about the unit circle. How do we determine if we have the short leg or the long leg given to us? Look at the angle across from the leg, right? So in MNO there, is 8 short or long? 8's our short leg, right? So we go from our short leg to go up to our long leg, we multiply by I was waiting until I heard more than one answer. Look, check your cheat sheet. The long leg is the radical 3, right? Because it is the smaller value. So MN would be radical 3 times 8. Whereas NO would be 16. So if you want, this might help your brain. I remember doing this and it being useful, at least once. If you make a little reference, I'll do it on graph paper. I started drawing this whole crazy unit circle thing that we were going to do, and then I bailed. So I decided to print it and get nice to you guys. If we do short leg, long leg, and hypotenuse, so we just had 8 radical 3 times 8 and 16, right? We are now given what? What is this side? Hypotenuse. So we're going to put 6. Interesting.
Well then,
Try it on your own. If you want to make a reference in your table, short leg would be x if long leg is radical 3x and if hypotenuse is 2x. Or if we want to reference our hypotenuse, which is like what we're doing in the second triangle, what I shushed Alina on, how do we find our short leg? Check your cheat sheet if you need. My short leg is half. This is so weird. Radical 3 over 2. Because if we come back up here where we were given the hypotenuse, and here's the trapdoor you're going to fall in, what is the short leg here? crap, it's half of it. Right? The short leg is half of the hypotenuse. What? Go ahead, speak up.
Figure out the short leg is just like if you think about it backwards. So for example, if the short leg was 4, then you would just multiply it by radical 3, so you can just take away the radical 3.
Are you sure about that?
Yeah, because you're dividing.
You just fell in the trapdoor I warned you of earlier and you got all snarky about. 2 is your hypotenuse, not radical 3. Here, our hypotenuse is using radical 3. But in our cheat sheet, the leg uses radical 3. So, Alina, I am not an I told you so kind of person, but you fell in the trapdoor I warned you about. To get from your hypotenuse back to your short leg, it is not the radical 3. That's just there to be annoying. It's actually a relationship of 1/2. You might want to add these 2 references to your table of if I have the short leg versus if I have the hypotenuse. So if we have the hypotenuse, take half of it to find your short leg. I'm just going to put 6 radical 3 over 2. I mean, or we could write 1/2 of 6 radical 3. But that leaves us with our long leg is going to be radical 3 over 2 times the hypotenuse. So this is going to become radical 3 over 2 times the hypotenuse value of 6 radical 3. Wait a minute. Wouldn't that, I'm going to grab all of this and bring it out here because I have a question. I'm going to pull my camera up a little bit. So, if this is all over 1, right, 6 radical 3 could be over 1, then I now have radical 3 times 6 times radical 3 over 2. Guys, what can I do with that? Sorry, do I need to shut one of these windows for this later? Does that help, or is it? It's the high window, isn't it? Sorry, it's the high one. So if I cover up a little bit more and bring this where you might be able to see it a little better. What can I do when I have radical 3 times radical 3? That's just 3, right? So this is really 3 times 6 over 2. Which is, okay, so 18 over 2. Oh, this simplifies real nice. It's 9. So wait. If our hypotenuse has radical 3 in it, the long leg ends up canceling out the radical 3. Right? Is there anything else we can do to simplify it over here?
You can just make it 3 times radical 3.
Ah. We can do the division because remember commutative property. We can really do like whatever order of things we want. So this is really 3 radical 3. Oh yeah, because 3 radical 3 would be half that of 6 radical 3. That makes sense. Yeah, so that I kind of wrote that more complicated than it needed to be at first. I know this may not make tons of sense yet, but does this at least make a little bit of sense of why it was kind of a trapdoor and how we got the values that we got of a simplified long leg of 9, a hypotenuse of 6 radical 3, Actually, if we go back and work it backwards, wow, that would be tough, right? Because then the long leg would be our radical 3x, or x radical 3. Let's make sure we can solve that third one since they do give us the short one to start. So since they give us the short one to start, that's like having our x on our cheat sheet. So to get from our short leg to our long leg, what do we multiply by? Radical 3, right? So if we multiply by radical 3 here, well, 2 radical 3 times radical 3, what's that going to come out to be? Just 6, right? So that's 6. And then we double to get our hypotenuse, so we just get 4 radical 3. Any questions on those? Because you got 2 more to do. And you're really doing those on your own. Try these. Guys, having a reference table, like what I've written in my notes, is a good idea. I'm not saying that as like, I want you to do this and turn it in for any reason. I'm just saying it's a good idea because it helps your brain make sense of this. We don't have a cheat sheet for when they give us the long leg. Can we make our own? Do you think we can make our own version of the cheat sheet for when they give us the long leg? Because what they gave us up here was when given the short leg or when given the hypotenuse. But what if I make this the thing I start with? Like, so what if I say L? Right, L, what if I start with L? How do I go from L to the short leg? Yeah, we're going backwards, so we divide by radical 3. So, L divided by radical 3. Yeah, and then for the hypotenuse, now that we have the short leg, we can just say, okay, so double that. So 2L over. Right. So really, if we want to write this in another way, we could say 2 over radical 3. That value. Wow, these weird numbers. Don't you wish there was like a button on our calculator that we could push that would do this math for us? Working with like 2's and radical 3's. Man, wouldn't that be nice? Wouldn't it be really cool if like somebody took the time to program a calculator to do all this math for us, since we know that these things are always true? Would be sweet. All right, so right here our short leg is 6 over radical 3. And that makes our long leg, we can write it like we just said we could. 2 over radical 3 times, or we could do 12 over radical 3, right? Okay. Wait. do we just not want to like talk today? Alright, never mind. We'll come back to things. What about this? What's our long leg? Crap, they gave us the hypotenuse. These, let's write it out, right? So we have a 12, a radical 3, and a radical 3 on top. So the radical 3's cancel. Well, the radicals cancel. What's 3 times 12? Divide by 2? 18. And then, well, now that we have our long leg, we could use this part of our reference table if we want. So we could say it's 18 divided by radical 3. Or we can go back up here and say it's going to be half that. So wait, what we're saying is 18 divided by radical 3. Is that equal to 6 times radical 3? Right, hypotenuse, half of the hypotenuse. So 6 radical 3. Apparently these should be equal, right? Because those are the two different values that we could get if we use the references that we've created. If I go from the hypotenuse, my short leg is half of that. If I go from my long leg, we divide by radical 3. So try these. Grab your calculator, try these out. What is 6 radical 3? I've lost my calculator.
Oh, that's not a happy number.
10.39 something. And then do 18 divided by radical 3. 10.39 unhappy number. So these are the same values. Because if you are doing work with somebody else, which I'm all about, we might get 2 different expressions that are the same thing. Right? 2 times 3 is equal to 6 times 1. It doesn't mean they're different numbers. We used different numbers to get there, but they're the same thing. Make sense? That we can get 2 different expressions based off which way we go, like what part of our cheat sheet we use. Yes, maybe. So let's talk about where the heck this comes from and why unit circle is involved. That is, if I have time left. I have not even 10 minutes. Alright, so take a moment and just inspect your unit circle that I handed out to you. Look over here. Look at what's in black, what's in red, what's in green. I know some things got cut off on the top and bottom. Sorry, I liked the colors that this provided, so that's why I chose this print, even though things got cut off on the top and bottom. We can fill those in, actually. What is a full rotation? 360 degrees. Okay, so let's start writing down something. So a full rotation is 360 degrees. But what about building a car? Right? And I'm trying to decide how big of tires to use. And you guys are like, well, it doesn't matter because one full rotation is 360 degrees. So I'm like, all right, so one rotation, right, versus one rotation. Are these different size wheels going to get me the same place in one rotation? No. But are they both 360 degrees? Crap! Alright, so we can't, 360 isn't good enough. Yeah, I didn't throw the water, so that's fine. Crap, how else can we talk about a full rotation?
Circumference.
Okay, So a full rotation is also the circumference.
Is that like a full circle, like 2 pi or something?
And the circumference is 2 pi r. So, this is not the repeating. Actually, I'm going to put the word so. If r is 1, if r, the radius, if r is 1, we can break apart our circle by the circumference. So what this this is hard because I'm going to write on top of a lot of things. What this pi value is actually giving us is the amount of what we call, anyone? Starts with an R. Did you say R? When I said it starts with an R. That is the amount of radians. Anyone ever have somebody tell you make sure your calculator's in degrees, not radians?
No.
Wow. I hope you guys did okay on your Math 1 test then.
I don't have your first confused.
In your TI 84, when you go to the Math menu, no, not Math, Settings. How do I get to Settings? I haven't done this in so long. Dang it. I should have prepared. Mode! That's the button I'm looking for, not Math. Your calculator normally is in degrees. However, if I hit my reset and I clear my memory, guys, this is important. If you hit the reset and clear your memory like they make you do when you go take the ACT or SAT, actually, I don't know if they make you do that anymore, but they used to. Look what happened. My calculator's mode defaults to radians. So when I go to do sine, if I type in a degree measure, my calculator's like, what? What are you doing? I'm going to give you a negative number because I don't know what's going on. As opposed to, if I type in, I don't know, pi over 6. Pi. Oh, look at that nice number. So, this is the first thing you need to know, is that radians versus degrees is in your mode menu of your calculator. We normally want to be in degrees, but we're often going to work in radians now that we're getting into trigonometry. Watch, and now if I hit enter again to do the same question, watch, same question, different answer. This is how you can freak people out and be like, my calculator's broken. I did the same question and got 2 different answers. If you change your mode in between calculations, remember we talked about this is a really dumb computer. Because now on your screen, it makes it look like the same math gets you 2 different answers. It does, depending on what you're calculating with. Here, the input, it was expecting radians. Here, the input, it was expecting degrees. And pi divided by 6 is a very small amount of degrees. It's a very, very small number. So, the next thing with my 3 minutes left. Jump over here. Cosine and sine. We'll get to tangent in another day. Cosine is actually the x value of the triangle, which is the long leg, in this case at least. The sine value is actually the y. And you don't need to know this stuff yet for your Khan Academy. all you really need to know for what I've assigned you so far is the special right triangles 30, 60, 90, 45, 45. That stuff will get you through your Khan Academy. But I always like to intro the unit circle way before you actually need it. Can anyone make a guess what I should highlight orange? Since when I started talking about distance, my wheel can travel as it rolls. How could we figure out how far that's going to go? What part of that circle would we highlight? Are we going to highlight something inside of it?
I think it's the outside.
The edge, right? So the amount of radians is this distance. It's the curve. It is literally the curved distance traveled. So if you were to lay that curved line out straight and measure it, it's pi over 6 times 1, because that's your radius here. If your radius is not 1, if you're not using the unit circle, things change. But guys, the thing that took me I will admit, it took me longer to realize than I should have. The reason it's called the unit circle is your radius is 1. That's why it's called the unit circle, because your radius is 1. That's it. That's why it's called the unit circle. Everything else is scalable. Like the whole thing is scalable. The only reason this is special is it's a radius of 1. It makes the math easy. But as you can see, it's not easy. Alright, we will pick this up next time. Have a wonderful day, guys. I threw too much at you, so all you really need to care about is the special right triangle stuff. But hey, what would it be if I wasn't over teaching? What's up? Let me stop this recording and give it a title really quickly, and then I will help you.